I'm Shuyu, a junior undergraduate student from Shanghai Jiaotong University. I initially make this video in order to introduce two of my research experiences related to biophotonics, recently combined with graduate students. In the lab of optical nano device, we developed a fingerprint recognition device. Why we do this is basically by seeing the popularity of fingerprint detection in display industry. Current touch screens use the resistive or the surface acoustic wave or the capacitive or optical touch sensors to collect info. Among these types, the resistive pressure sensors are eliminated due to the large hysteresis, and surface acoustic wave type is sensitive into the humidity. Thus, it sets the high demand for the fabrication and reserve. As for the capacitive one, which works by changing the quantity of the electricity of the capacitance between the electrodes, is a fast response, and nowadays it dominates the market. However, this capacitive one is limited in the separating of the touch panel and the fingerprint recognition model because of the resolution requirements. Thus, it will cost more store space as well as the money costs. We developed the optical touch sensor based on the frustration of the total internal reflection, which combined the optical touch screen with the fingerprint recognition, and it could help fill in the niche. The structure of the device could be seen from the paper if you'd like. Basically, we use the slanted nanogradient to guide the wave. Here I want to explain that why we use the slanted gradient instead of normal one is that due to the diffraction equation, when the inside light is coupled into the slanted gradient, it would propagate in one direction instead of the multi-modes. Thus, we can make the precise detection more efficiently. And besides, the basic idea of the fingerprint recognition is that the total internal reflection between air and waveguide would be destroyed by the ridges of the finger when pressing on. Thus, the info is collected and stored in the detector. For more details, please have a look at the theory and numerical simulation part in the paper. And I want to add that as an undergraduate student as well as a student from the animal background, I see into this project for further bioidentification applications. For example, the fingerprints could substitute the passcode for groups of the forgetful people, such as the Alzheimer disease holders, in order to help them build the independence in daily life. And in the medical system, it could be used to large quantities of the real name authentication of the patients. Besides, I believe based on the frustration of total internal reflection, other characters of organism could be recognized also. This work would be introduced in the SID, the Society for Information Display. It's a display week which will be held in May 21st to 26th, located in Los Angeles. Okay, for another part I have conducted before is based on the surface plasmonic resonance, which has been broadly used to the biomolecule detection because of its sensitivity to ambient refraction index. In order to control the SPR, I innovatively used the electrowetting device, the EWOD electrowetting device of the dielectric device, to make the resonance peak shift. Yeah, we can see the color shift in a macroscopic length. So if you have the interest in it, I put a tattoo file in a mail, but I want to apologize for I just put it in a Chinese mode. If you have the interest, I could explain it to you later. This project is still limited in a biomedical application because I initially conduct this in order to develop a high performance transmissive display. So recently I'm trying to apply this into the real-time biomolecule detection in the liquid environment. And I want to show you this is one of the electrowetting device which haven't combined with the electrodes, but we can see the color shift when we put a dot of the water into the surface of this subpixels, and by changing the inside angle of the lens we can see the different color. Yeah, thank you.